Hello everyone, this is Dell here talking about frequencies today. There's been a lot of information on the internet and out in the world today about the solfeggio frequencies. So we're going to start this first lesson going over the solfeggio frequencies and comparing them to tuning systems that have been around. First of all, we'll just go over this chart. Here we have the solfeggio frequencies down here. They're listed as 396, and these are hertz, which they called ut or oot, and it really is close to a G above middle C on the piano. 417 they're calling re, which is close to a G sharp above middle C. 528 is the octave above middle C. 639 is somewhere between an E flat and an F. This is an octave and a half above middle C. Then you have 741, which is close to a half a step higher at F sharp. And then 852, which is a G sharp or an A, somewhere in between those. It's not exact in any of the tuning systems. So the ones that they're in between the pitches, that it's not fitting any tuning system that we know of. Okay, if you will look up here, here are the different tuning systems that have been in use over several years. And if you go and look at down here, what I've done is all of these tuning systems, you can see how close the particular pitch is within that tuning system. And if you're wondering where I got this, let's go to and we're going to look at the frequencies of musical. This is a website. It's www.phy.mtu.edu. I believe it's Michigan Technical University. You can, on this particular chart, it's a physics site, frequencies for equal tempered scale. This particular one is 440, but you can click on 432, and you will notice that as you do that, all of these numbers change. 434, 436, 438, and as I'm doing this, you're going to notice all the numbers are below that are changing. So let's go to the 444, which is where you're going to find the 528, which is what they're discussing. So you just go all the way down. This is the octaves. This is the very lowest octave on the piano. This is the next octave higher, etc. And you go all the way down until you find 528, which is right here. And this is the C above middle C. So I basically transferred that information onto this form here. So if you look at 432, you're going to notice that none of these pitches fit within the 432 tuning system. Then the same thing in the 434. Now 386 is only 1 cent away, not 1 cent away, it's 10 points or 10 cents away from 396. It's going to be close, and unless your ear is really tuned to it, you're not going to hear it as much. And none of the others fit within the 434 tuning system. Then you have over here a 436. We're getting closer. 388 on the 396 one. We're close on the re. So we'll just refer this to the oot. We're close. We're within 6 cents on the re and within 10 points on the mi, and it doesn't work on any of the others. Now we go over to the 438, and you'll notice as we're getting closer, I start putting pitches in, especially if it's within 10 cents of the original pitch. As you'll notice, we have 3 or 4 here that are pretty close. The 639 does not work in any of them, and neither does the 852. Okay, so we go to our current tuning system of A440. We're getting closer. As you go down, you see that the yellow I have here shows 741 for sol, is in between the A440 you see up here and the 442 tuning system. So there's your 739 and 743, and the actual pitch is somewhere in between. So it would probably fit if there was a tuning system of 441. Okay, so now we're going to the 442. The 417 is an exact match in this tuning system for the re. Then if you go into the 444 system, you've got the oot at the 396, again 395 on either side in the 444 tuning system to the A446. It's going to be one in between both of these. Then you'll notice the 528 is the only one that fits within the 444 system. So if you tune your instruments to 444, the only one that's going to be an exact match is the 528. The 396 will be close. The 417 will also be close. The 639, no. The 741, it'll be enough difference that you would probably notice it, but it's not a lot. So these are going to be close, but they're not exact. Then if you go to A446, the closest one is going to be the 396. So in looking at this scale, which is what they're calling the solfeggio frequencies, oot being the lowest, or in the scale wise, oot, re, mi, fa, so, la, in the solfeggio frequencies. And if we scroll down here, you can actually see what they're saying that those frequencies represent. Oot, turning grief into joy, liberating guilt and fear. Re, undoing situations and facilitating change, etc. And it goes on down the list. Okay. So I believe for that particular one, I think we're going to go back to this particular video here. If you are listening to a major scale from the time of when the solfeggio frequencies came about, all because of a man named Guido of Arezzo, which we'll get into that in the second video. This particular video, and I need to give credit where it's due, is by a person named using the screen name Transcendental Tones. All I did was Googled solfeggio frequency tones, and this was one of the ones that came up, and I was curious. And I like the video because he actually has some sort of a tone generator that will produce the tones in the various pitches. At the time that Guido of Arezzo wrote out his solfeggio frequencies, he was using Pythagorean tuning, which was used from the 4th century all the way through when they started working on well temperament and just intonation, and that all came before the equal temperament. Okay, so we're going to listen to this section of the video for a second. Okay, if you're hearing that, you're going to notice, I'm going to turn it up just a little bit louder, and we're going to go back and listen to that again. I believe it's 1 minute exactly. You'll notice in the regular scale, that is our tuning, our normal scale for equal tempered, and then immediately following are the solfeggio frequencies. Okay, so now I'm going to skip over to where he talks about Pythagoras, and that's at 153 if you want to go watch this video yourself. So here we go. Let's listen to the Pythagorean major scale. You will notice it sounds really close to our current scale. Okay, and I'm not going to play the chords, but you will notice that the last two pitches are slightly off. But if you compare the Pythagorean tuning with the tuning of the solfeggio frequencies, they're not even close. And we do know, based on historical fact, that Guido used the Pythagorean scale, so therefore his musical notation and everything that he did was based on that scale. So let's go back and listen to that scale one more time. We find it here, 153. Okay, and Kepler, I was going to stop there, is associated with that. We're not going to go into Kepler at this point, but you will notice that the tuning is extremely different in the solfeggio frequencies as it is opposed to the Pythagorean scale, which was used at the time of Guido. Okay, so that's it for this lesson, and then we're going to go more into Guido once we're in the next video. So thank you for watching.